Hey, wonderful physics superstars, Jock here. Hope you have your notebook and a calculator ready. I'll wait while you get it, because you're going to do some pretty good learning with me today. In fact, I'm willing to guess that you probably already heard this video before and you're going back to it to help study for future things, which is fine with me. But we're going to look at the kinematic equations today, which we're using throughout first quarter and actually half a second quarter as well. So this information is going to be pretty vital. Here's the major idea. You're about to learn some really complicated equations to figure out how displacement, velocity, acceleration, and time relate to each other. Like always in this video, I highly encourage you to pause, rewind, make notes to yourself, write down questions you want to ask me, because this is it. This is where physics takes the tough road for you. You must be really good at reading a situation, picking out information, picking out important words, and organizing it. A wrong assumption or even missing a single word and not knowing what it means is the difference between getting something right, understanding it, and being totally in WTF land. Thankfully, you're smart. I have strategies. Together, we're going to kick this thing's butt. So the equations. Here they are. They're on your formula sheet, thank heaven. Here are the four of them. You should write them down right now. If you have your formula sheet handy, you can see them in the top left as well. But these ones will be known by you, especially this top one. You're going to memorize this even though you don't have to, because it's used so dang much. There are 5 key ideas in kinematics. These are the 5 variables that these equations have. The first one I want you to meet is initial velocity, VI. It's the starting velocity of the time segment in question. Notice the capital letters there. Yeah. VF is the ending or final velocity of the time segment in question. So, for example, if you throw a ball up in the air and you want to see how high it goes, the starting velocity is in your hand. The final velocity is at the top, even though it comes back down to earth. Or if you throw something up and I want to say, hey, how far to go from the top down to where it hits? The starting velocity is not in your hand, but at the top. And the final velocity is at the bottom. So initial and final velocity are just kind of like 2 endpoints that you could choose based on the situation. D is displacement of the time segment in question. So if you throw something up and it ends back in your hand, displacement overall is 0. But if you're looking at from the top to the bottom, it's not 0, because you're looking at from the top down. And since it's down, displacement would be negative in that case. So we got to deal with negative and positives. Oh, geez. A is the acceleration of the time segment in question. And finally, T is the time segment in question. Yay. Strategy number 1. I think there are 5. Underline, look for key phrases. One key phrase, drop, rest, or stop. Velocity is 0 for that moment. If you start from rest, VI is 0. If you end at a stop, VF is 0. Constant velocity. If you see that, it means acceleration is 0. In the air, if something's in the air, the acceleration right now is due to gravity. Look out for directional phrases like the phrase like slowing, back, or down. That'll let you figure out the direction, and the direction can figure out if it's positive or negative for that variable. Like, for example, you throw down something at 20 meters per second, the starting velocity would be negative 20, because down is negative. And finally, look at the units. Meters per second is velocity. Meters per second squared is acceleration. Seconds is time. Meters is displacement. This is 2 parts. First of all, if you see a number you have no idea what it means, the unit will tell you if it's a velocity, acceleration, or time, or meters. Finally, you can also see if you convert. If you see minutes for something, you know you get converted to seconds. And a lot of you forgot to convert to seconds on one of your classworks earlier in the weeks. Please don't do that again. Step 2, draw a picture and number line. Drawing a picture will help you out along with a number line. You must do this. If you don't do this, I'm going to be sarcastic at you, and I can be devastating in my sarcasm. If it's moving up or down, as us people like to say, draw a vertical number line. Don't just draw one that's forward. Let the picture match what you're doing. And finally, what we're doing in a little bit is mark where the information is occurring on the number line. You'll see what I mean in a little bit. I'll call it back to this. Step 3, here we go. Make a chart of information. If you just have numbers all over the place, you are going to fail yourself. You're not going to do as well as you should in this class. And I don't want that to happen. We're going to make organized little charts of information to help us identify what's going on. So you're going to make a chart of the 5 things that we have. Those 5 things from before, VI, VF, blah, blah, blah. Include a positive or negative one, except for time, because that way you don't forget it. If you don't know a variable, leave it blank. If you're trying to find it, put a question mark in. And finally, if there are like multiple time periods you're looking at or accelerations, you may want to take a table for each one. Don't worry about this so far, but just in the future, you don't have to fit it all in one table. Finally, once you know 3 of the 5, you can find the other 2. So once you know 3 of them, you can use equations to figure out the other 2 that you need. 4, try and solve. From your table, find what you're looking for and everything you have, and choose the correct equation. Then, and you're going to hate me for this, but I don't really give a rat's patootie, write the equation out entirely, just the letters. And then underneath it, write down the numbers that are supposed to go where. So don't just start writing numbers and doing math. I will quite literally try to hurt you emotionally, because this is the easy way to screw up. Write out the entire equation, then underneath it, write down the numbers you're going to put in. Finally, number 5, you're going to solve it. Solve the equation, showing every step on the paper, not just calculating it. If you just do it on your calculator, you're going to have a lot of trouble. I have a physics degree, advanced stuff, and even I write it out because it's easy to get screwed up and make a mistake. When you finally get a result, check and make sure it makes sense. Time is negative, that doesn't happen. And then check your units. Here's our example. Ooh, that should be hidden, but I don't care. A car is going 20 meters per second, and it deaccelerates at a constant negative 0.5 meters per second squared by letting up the gas. Calculate these 2 things. Pause, write this entirely down, wait for, once you're all done, press play again. Welcome back. Step 1, key phrases. I see constant negative acceleration, though. It doesn't say constant velocity, so the acceleration is not 0. Letter A says I'm trying to find time. B, I'm trying to find displacement. The car is going this velocity, so that's the starting velocity. And since it says stop, that means the final velocity is going to be 0. Number line or picture, draw it out. Here's mine. Look at that. 0 to 12 in terms of seconds. I don't know if it ends at 12 seconds. That's because I'm going to write little arrows in. At the 0 second, at the first moment, it's going 20. And whatever time it takes to stop, I'm putting it outside the number line because I don't know what it is. The final velocity is going to be 0. Now let's make a chart of information. Here we are. The acceleration is negative 0.5 meters per second squared. Initial velocity is 0. Final velocity is 0. Whoa, initial velocity is 20. Final velocity is 0. And we're trying to find the time to stop and the displacement from start to end. Step 4, let's choose the correct equations for A and B. So I want to find an equation with these 3 things and time for letter A, these 3 things and displacement for letter B. And now we're going to solve it. So here's the equation I'm going to use for part A. Here's the equation I'm going to use for part B. To solve it, let's do it. Here's the information we have and the equations. So first of all, write out the equation. Underneath it, let's write down the numbers we have, and let's solve it. See what I got 40 seconds for letter A. For B, write out the equation, write stuff underneath it. See how I solve for letter B. Can you please now pause, copy this down, write no notes to yourself, make it make sense. If you didn't get it, please bring it up to me in class next time. Okay, you're back. Here's our last example. Same as before. But now, how far did it travel in the first 5 seconds? Please pick out your key phrases. I'll wait. Cool. Is the final velocity 0 here? We're going to say no, because it's final velocity after some amount of time. But in the first 5 seconds, it's still moving. Step 2, make your number line or pick. I'll wait. Here's my number line. That's what we had before. But now we're trying to find it from 0 to 5 seconds. The velocity here is not 0. It's at some number. Chart of information. There's our information. Notice final velocity is not 0. The acceleration is still negative 0.5 because it's constant, which means it's the same for every second. And we're trying to find after 5 seconds. Pick the right equation. Choose it. I picked that one. And finally solve it. Can you please try solving it and see if you understand it? I got 93.75 meters. Now, if you're a really smart pen as we end up, you could use your physics to really help you out. Look at this number line. Starts off at 20 meters per second. This is the acceleration. So that's how much it changes by every second. So in 1 second, it changed by negative 0.5. It's now at 19.5. Another second, another negative 0.5, 19. 18.5, 18. 17.5. So the velocity at 5 seconds is 17.5, which is the final velocity. You could have also used that fact. With that, my wonderful students, you're going to be learning a lot of stuff from me. You have a quiz next time. Good luck. Take care.